well, just to break up the delivery. So as Andrew said, if you do have any questions, please put them into the Q&A box and we will be more than happy to go through them towards the end. Also note that this presentation will be available for download. There we go. That's all of the housekeeping out of the way. The place I want to start is talking about data, obviously. So here we have a large machinery manufacturer. You know, you may have seen these around the world, literally huge machines the size of houses that are highly instrumented, extremely expensive, and they require a lot of understanding in order to get the best out of them. So given that we know there's data streaming off them, how do we use that data most effectively? How do we use that data to allow us to compete against competition in the market? What can we do in order to ensure that our profit margins stay at a good level? And then, does that give us options around maintaining or raising our price, or can we add that in a different way? So one way that this operator was looking to increase their margins, increase their bottom line, was to understand the maintenance cycles around these vehicles. So we all understand being able to use IoT data and streaming data to predict maintenance cycles, but how does that also interact with our maintenance schedules, our resources available, even just the technicians in order to service them? And this was presenting a problem. It was actually becoming quite inefficient because they were over maintaining or over servicing these vehicles, or not servicing them often enough, in which case, they're breaking down, being out of the production cycle for a period of time, which effectively costs them millions and millions of dollars. So what this particular organization did was introduce Denodo as a data virtualization layer that allows them to seamlessly connect or logically build a unified data model across all those disparate data sources, regardless of whether it is that IoT data that's streaming off those big devices, or whether it's their operational systems all around parts and maintenance and even the dealer systems. So using that single platform of data virtualization, they can now do that unified operational reporting, so to provide the predictive analytics and understand exactly what is required in order to maintain the health of their machinery, of their infrastructure, as well as being able to understand what impact that has on their bottom line. The end result is that now they could improve the performance of their asset and be far more strategic about the maintenance cycles. And this resulted, in increased revenue, because not only could they reduce the number of parts that were being replaced unnecessarily, but they could, in fact, understand whether those parts could be sold on to other organizations or redistributed around their network. Ultimately, though, it also provided another form of revenue for them, because they could sell all of this information, all of these findings, this value that they got back to those suppliers of parts, and so get an extra stream of revenue. This is just one example of the challenges associated with data management in the current environment. If we take a look at three high-level ones, obviously everyone wants their data faster and have it more accurately. So in order to meet the significant increase that businesses wanting to make changes, to implement, to innovate, all of this has to happen within the increasing complexity. In addition to that, this all has to be delivered within an environment that is got increasing levels of regulations, whether we're talking about internal regulation and governance for your organization and how the data should be used and where it should be located and what purposes it can be used for, or even the external regulators, such that about data sovereignty, privacy laws, such things as GDPR. All of these regulations have an impact on how and where this data can be used. In addition to that, we all understand that data is growing. The number of internal systems that we have continues to grow. And we don't necessarily have the growing budget to meet that. So how do we deliver faster, meet the regulations, and keep our costs at the current level or reduce them, all within the current environment? And these are challenges that we see right across the market, regardless of the industry. And if we take a look at why these are challenges, so here we have, admittedly, a very simplified architecture, where on the left-hand side, we have all of our IT and data sources, whether they're on the premise or in cloud or even software as a service. And on the right-hand side, we have all our consumers, whether we're talking about real-time dashboarding or operational reporting, or even advanced analytics, machine learning, and sort of predictive outcomes. You can see that what we end up with is this point-to-point integration between all of the consumers and all of the data sources. What we're not seeing here, though, and we don't really see it until we start to drill in to another level of detail, is that this means that we have to have all these additional levels of governance and security on each individual silo of data, because we don't have that unified view of the landscape, and so we have to ensure that each individual system is got the appropriate governance and security rules. In addition to that, on the consuming side, we end up with all of these silos of business logic, where each tool, each consumer, has its own logic. So not only is this complex to maintain and change, but it also starts to introduce risk around misunderstandings or even inappropriate uses of data. So how does this really come about if we take a look at a modern data architecture? So here we've got a representation of an architecture whereby we've got all of our structured data sources, such as our relational databases. And we're all aware of all of the unstructured and semi-structured data, log files, emails, IoT data, et cetera, But in order to use all of this data, we then have to have different patterns, different styles of data ingestion, so that we can get it from those source systems through to the consumers. On top of that, we might have different applications, whether they're software as a service applications, such as Salesforce or ServiceNow, or they might be in-house applications. All these applications need somewhere to store their data, and so we end up with all these different types and styles of data storage. And we also end up with all these different ways of processing this data, maintaining the data, whether we're talking about Hadoops or Presto engines, or even your traditional relational outcome engines. And then we go to the right-hand side, and we've got, again, all these different consumers, all the different requirements around dashboarding, reporting, advanced analytics, data mining, and even just to support discovery and self-service of the data across the landscape. And what we're left with in the middle here is this data access layer, where we end up with all this complexity around having different styles or different ways of getting to access to the data based on the outcome we want to achieve, the data source we're talking to, where that data resides, and how fast we want it. And so this is what gets then reflected in that complex architecture or complex integration landscape with all of the point-to-point integrations. So what I'd like to do is just pose a quiz to you that across your organization, where is the data for your data lake located? Do you have it in the cloud, on-premise, both in the cloud and on-premise, or we don't in fact have a data lake? So you should have on your screen now the opportunity to answer that question, and then click the result, click submit, and we'll just give it a moment, and then we'll be able to have a look at what those results are and just see how it, for our audience, see how it lines up with what we're seeing in the general marketplace. So please just answer that question, and we'll give it another 5 or 10 seconds, and then we'll just take a look at those results. So we'll give it the 5 seconds, and then can we see the results there? Okay. Very interesting. It's not quite what I expected, in that we have the majority of people don't yet have a data lake, which that's okay. But then of the people that we do, we've got a very even distribution between on-premise and in the cloud, which is what we see a lot of customers actually do this, where they're leveraging the power of the cloud in order to be able to use the resources there, the ability to expand both infrastructure and compute and storage, so that we can burst as required, but then minimize the amount of outcome. As you'd appreciate, this also presents a challenge for organizations, because now, even if we have our cloud, our data lake only in the cloud, it still means we have data on-premise. And for those people that are in both cloud and on-premise, I'm sure you understand some of the challenges of getting that unified view of the data. And that's where data virtualization particularly can help us. And we'll explore that a little bit further. If we just have a look at how Gartner view the rise of logical architectures or the evolution of analytical environments over time, we can see that in the 1980s, we had monolithic systems where it was quite likely that each organization literally had one system, one large system. And so it was actually quite easy to go and get that single view of data, because you just go to the system, you get the data, and it's done. Then as we move into the 1990s, databases start to become commoditized, they start to become far more accessible, and so we end up with organizations having more than one application, more than one repository of data, whether they're located in the same geography or we start to get geographically distributed geographies. In order to cope with that, in order to be able to get that single view or that unified view of data, the data warehouse is born. We then move forward into the 2000s, and we're getting even more data. We're getting, more operational applications. We're getting software as a service. We're getting data that's highly distributed. And so we see that we have both the data warehouse and the data lake really come into their own. And they're great. They solve some really pressing problems, but they don't solve all the problems. It still leaves some challenges. I mean, how do we cope with just literally terabytes and petabytes of data? How do we cope with data that's external to the organization? There are these challenges that still persist with the data lake and the data warehouse pattern. And this is where Gartner introduces the data virtualization, whereby we start talking about logical data warehouses, logical data lakes, logical data stores. So we're building that logical layer, that logical view across all of our data, regardless of where it's located, so that we no longer have to build that monolithic system just in order to cope with the sheer volumes of data. It also means that we now can reduce the amount of infrastructure that we require, because we don't have to have data copied in multiple places. We can just reference or access that data in one spot. And we've in fact seen that this can improve both speed to market as well as consistency, and really reduce the amount of cost and infrastructure required in order to maintain that single view of data. So let's take a look at what a data lake is. And this is probably could be debated for quite a while, but for today, we'll just stick with this definition of a data lake, where it's effectively a cost-effective storage repository that can hold vast amounts of raw data that can then be used for analytics and data science and for any outcomes that we want. The point being that we can literally put anything we want in here in a cost-effective manner. Data lakes are generally considered a place to go for data for a skilled practitioner, a skilled user, whether we're talking about a data scientist or an analyst that literally understands how to get to the data, how to use the data, you know, how to manipulate that data, given that it's not a unified or standard interface most of the time. And so while data lakes allowed us to get that the repository that contains the complete view of the data, it doesn't necessarily allow us to get access to the data because we have to have the right skills. And so we see there's some challenges with data lakes themselves in that because they are physical, they have to have copies of the data in its physical storage in order to be able to effective. And it's not appropriate for all data sets. I mean, how do we cope with real-time data sets? How do we cope with data sets that aren't allowed to be copied from their place of origin? Handling those sovereignty rules. In addition, they tend to be single purpose. I say tend because they're not always single purpose, but they tend to deliver a single outcome simply because of the level of skill and understanding that's required. The other thing there, though, for most organizations is that the level of governance, security, understanding, meaning of the data in a data lake doesn't necessarily meet what users expect from the other data sources that they've got, such as the enterprise data warehouse or the reporting data mart. There can be this disparity between meaning and understanding between the two silos of data. And so that's a challenge that we have to solve. And so the way we talk about solving that is to introduce the concept of a multi-purpose data lake. A lake that does allow access for every consumer across the organization. And we can enforce a known and reliable level of quality and governance and understanding. Ultimately, this allows us to drive a high level of reuse of that data, meaning that we get a better return on our investment. So what does the first step, what does a logical data lake look like, and how do we get that multi-purpose use out of it? So taking a look here, we can see that we've got that simplified architecture again, whereby we have our data warehouse here, we have a physical data lake, we have all of our source applications, and we even have some streaming data coming into our data lake. Over on the right-hand side, we still have our consumers, but now rather than talking directly point to point to each of the underlying data sources, each of these consumers now talks to the Denodo data virtualization platform. All of this is then encompassed in this red boundary here that we're calling a virtual data lake. So you can see it logically groups all of this data together in one entity. What this now means, though, is that these users, these consumers of the data, can ask Denodo, ask the data virtualization layer for objects, entities, nouns, everything that's been modeled in the underlying infrastructure. So we can now, at this data virtualization layer, have a consistent view of the enterprise entities. And we can then take those entities and evolve them into line of business or specific outcome or external data sharing. The point being that regardless of what view or what slice of the data we take, it all originates from the same underlying data source. The reason that this is now multi-purpose is that we can provide a unified, consistent data platform for all of these users. So it doesn't matter what role, what responsibility, or what outcome they're looking for, they can now all go to this single access, this single layer. Denodo is able to do that, to provide that power, because it's not actually copying all of this data into the platform. It's taking the metadata, using that metadata to build logical views, allowing data modelers to enrich and join and enhance that data, so that now when a query is run or a request is made, that request is abstracted out from the whole complexity of this underlying architecture. It also allows us to be far more strategic around what this underlying architecture is, in that we don't need one of everything, we just need the right strategic platform to get the right outcome for that set of data. A similar publicly available virtual data lake is Denodo's coronavirus data portal, which is, and there'll be a link a bit later on. This is where we're using Denodo to present everything out through a very easy to use data catalog or self-service shop, where you can see it allows all of these consumers, whether we're talking about people just wanting to discover new data sets, or whether we're having users wanting to do some in-depth analysis based on some source data. The point being, or the value that we're offering here, is that all of these data sets here, which are from a huge array of organizations, both government, non-government and private, are now able to be unified in this single portal without having to copy all the data in. And it's also available in real time. This means that all of this data can now be easily accessed, discovered, found, understood in a single easy-to-use graphical interface. And if you're in fact interested, then we welcome you to go to the coronavirusdataportal.com and actually log in, have an exploration around, and see how you can use this data in order to come up with a valuable outcome. So if we take a look at what the value of a multi-purpose data lake is, particularly delivered with data virtualization, it means that this, because of its logical nature, replication is an option. It's not compulsory. We now have options around how we manage and access our data. And in fact, we can add new data sets, new technologies really, really quickly, because we no longer have to worry about copying that data or re-platforming that data just to get use about it. In addition, it becomes multi-purpose because we have this single layer, this single place where we can curate the view of that data, make specific views and slices of the data for particular use cases. And I've said before, we ultimately get better return on investment because that data is being used for multiple purposes rather than that single purpose all the time. And so we can see now that that virtual data lake allows us to access all the data sources, whether they're internal or external to the organization, whether they're physical data lakes or other databases, or even just file systems or object stores that you may contain. It also allows us to be very efficient about how we do that processing. So it's still highly performant because we can use all of the capabilities within your landscape, including your physical data lake, in order to improve the acceleration of the queries. The Denodo Dynamic Cost Optimizer can, in fact, on demand, coordinate the processing with the different capabilities within your information landscape in order to reduce the amount of latency and so make that data highly available. We just quickly look through how Denodo can in fact use the external processing engines, such as an MPP engine like Hadoop. We've got this very simple example here, where Denodo is connecting to a sales table that might have 300 million rows, and in our Hadoop cluster, we might have our customer table of 2 million rows. What we're trying to do is build a report or build a view that connects the two data sources together. So when we submit our report, Denodo recognizes that the query we're asking for requires aggregations. And so the first thing we'll do is actually aggregate that data within the source system rather than pulling all the data back across into the platform and then doing that processing. The cost-based optimizer will then understand that we can move part, or in fact all of the required processing across to the MPP engine, so that we can do all of those high-level process, or that grunty processing in parallel. And so Denodo will transparently push that across, transfer the required data across, and then ask the MPP engine to do all of the joining, processing, everything that's required in order to satisfy the requirements of that query. Once that's done, in parallel, because that's the power of an MPP engine, the results are then passed back to Denodo and then delivered out to the consumer. So all of this happens dynamically and transparently to the user. The end result is that if we were just using a traditional integration method where we're moving data around, it might take approximately 10 minutes to do a similar query. Even with the Denodo platform and not having access to an MPP engine, it will take just under a minute, whereby we're leveraging all of the optimizations that Denodo has available to it in order to get that outcome. But with MPP engine, we can see that we further accelerate it again by being able to leverage that high throughput parallelization of the MPP engine, using everything that we have available within the landscape to get the most value and the most throughput. So this really brings us to a data fabric, and how a data fabric across your on-premise and in-cloud data sources can allow you to transform, prepare, set your security governance, and just allow very fast insights. If we take a look at the Forrester Data Fabric diagram, you can see here across the bottom, we have our on-premise data sources and our cloud data sources. They're all being streamed, in this case, into Hadoop engines, which are then going through a transformation, a data modeling, and a caching layer before they're then delivered out to the consumer. If we then take this architecture and overlay Denodo on it, you can see that Denodo is able, in one platform, in one engine, take care of all of this transformation, modeling and discovery, and data access and delivery. And so it significantly simplifies the delivery of that data fabric. It also adds flexibility and agility, and ultimately protects your information environment, your data landscape, from technological change. Because now we can, as we come up with new technologies, change the engine in here without changing the delivery of that data to the consumer, or interrupting delivery of that data. If we simplify this just a little bit further, you can see here, this is a representation where across the bottom, we have all of our different data sources, ranging from structured through semi-structured to unstructured, that can be distributed across premise, cloud, and applications. And we're able to use Denodo as a big data fabric that delivers that to all of these different outcomes, whether we're talking about operational reporting, analytical reporting, self-service, or governance. And so it allows us to abstract all the technicalities and presents out that single virtual repository for real-time delivery of data to our data consumers. If we take a look at our reference architecture, which you'll see has more boxes, more detail on it, I'd just like to point out a few things on this and how it references the previous architecture we were talking about. Here we have our data warehouse, our data lake, and our source applications. And you can imagine that without Denodo, for all of our consumers here, they would be building those point-to-point integrations into each of these sources. What Denodo does is remove the need to copy the warehouse into the lake, or the lake into the warehouse, data. In addition, because we're storing metadata, we can use all that metadata to present out a semantic layer to those users. So from a business point of view of customer, account, location, assets, whatever business entities the user requires. And from an IT point of view, we can also use that metadata in order to understand impact analysis, where all of our strategic assets are involved in the delivery of the data that our users are using. So just like that large machinery manufacturer, whereby we have all of this fast-moving, really small, data that in and of its own, each individual piece of data doesn't have much value. But when we start to unify it with all of our other data assets, that's when it comes into our own. And so this allows us to use the right system for the right storage and the right processing without having to copy or replicate or have additional infrastructure in our information landscape. Equally, another use case might be around offloading historical data, whether it's a data warehouse or an application, whereby we can offload the data from our historical data warehouse, in this case, and put it into a more cost-effective storage medium. It may be Hadoop, it may be an object store. Reporting and users' point of view, this is all transparent because they're now interfacing or interacting with Denodo, and Denodo is then taking care of where the data should queries will be directed straight into the Hadoop cluster. And then for the users that want to do queries across all of the data, Denodo will coordinate and get the results from both data sets, totally transparent. And I'm sure you've all got one of these. I think we all have one, because the next use case I want to talk about is an organization called Azorean. Azorean are an organization that provide warranties and insurance to digital devices. You're probably a customer of them because they don't sell their product directly, they sell it through the different manufacturers and telecommunication providers. In fact, they've got offices all around the world. And so they had a challenge because they wanted to be more timely, being able to provide new products and services in weeks rather than taking months, the months it was taking them to build that new product. But they also had to make sure that they were meeting those sovereignty regulations because all the data was across all those different countries of origin. And ultimately, they wanted to get that single centralized view of all the data so that they could be sure that they applying a consistent security model, a consistent point of control for all of the data. So how did they do that? They used Denodo data virtualization and built up a hybrid data layer, both across their cloud and on-premise data sets, that easily enabled them to add and remove new data sets. So as external data sets became available, they could very quickly be added into the architecture without having to copy them out of the country of origin. It also meant now that from a consumption point of view, all these consumers here would be accessing the data with a single consistent security model so that they could be sure that they're meeting all the regulatory requirements about where and how that data should be used across the organization. Very fine-grained role-based access control for the right use case. So that's a very quick introduction or overview of Denodo and the architecture of Denodo, whereby we can see that the data virtualization layer here is abstracting out, protecting, buffering the consumption of the data from the actual technicalities of the data. meaning that now the consumers of that data can be very agile, very quick about how and when they use those data sets without having to worry about whether it's on cloud, in-premise, in a file system, etc. Equally now, the IT infrastructure team can be very strategic about where and why different data sets are located in different locations without disrupting that data, the delivery of that data to the consumers. So if we go back and have a look at our requirements in data management, where we wanted faster, more accurate data, still while being regulated and reducing costs, we can see that data virtualization allows us to do that fast delivery of data because it provides that single platform, that single spot to go to get all of your data, regardless of what use you're looking for. And because we also now have that single layer, that single platform of access, we can ensure that we're unifying the governance and security of all the data. And then finally, we're minimizing the cost of the data management requirement because we're minimizing the amount of infrastructure, making the cost of change less or the impact of change far less. We're introducing agility, whether that's adding new data sources or changing requirements. So data virtualization as a platform, as a technology, allows us to meet all of these three requirements. And so what I'd like to do today is leave you with these three takeaways: that data virtualization is complementary to your environment, and it allows us to reduce costs, increase the level of aggregation, and allows you not to slow things down, but in order to speed things up so we can get access to data sources in real time, while supporting the requirement for users to get self-service, for them to fend for them, well, not fend for themselves, to find for themselves the data they want, to discover the appropriate data sets, still while centralizing all that governance and security that enterprise organizations are looking for. So thank you for that, and I'd be interested to see if we have any questions at all, Andrew.
We haven't at the moment, but please, down the Q&A thing, if you have any questions, just put those in. So I have a question around data governance, which seems to be a very popular topic at the moment.
Yeah.
How did the Denodo solution, contribute to data governance in terms of access and control around data and GDPR and all those sort of things?
Yeah, well I think the first thing around that is because some of those requirements are all around the physical location of the data, and so using data virtualization, we don't have to move it out of those countries of origin. So that's one thing. The second thing is we're now giving a platform that's unifying all the metadata in a consistent manner across the information landscape. And so while we're not actually a data quality platform, we're now giving you that single platform where you can consistently apply all of your quality and completeness rules. So rather than having to try and do that on a system-by-system basis, we can now do it in one spot. When it comes to security, the security model within Denodo is a role-based security model that can apply access controls on a table or a logical view, a row, a column, or a cell. And in addition to that, we can start to apply policies to say, well, this is an external user, so that external user should not have access to the date of birth. And so we could start to redact or hash that data out for those purposes. This all can be delivered in exactly the same view, so that from a data modeling point of view, it's still the same view, but now we're applying a consistent governance model on top of that using security.
Okay, thanks. So we've got a question come in from Julio. What sort of pricing model and costs for the Denodo platform?
Cool. So the Denodo looks and behaves very much like a relational database. So that makes it really easy to consume the data using your existing tools. But then because it's a database, you could also then think of it as a processing engine. So what we do is use a core-based licensing model where we're not counting the number of users, the number of data sources, the number of models that you may, anything like that. But we're using those in order to make sure that we have a platform that's large enough in order to meet your processing requirements. So for a operational requirement, it might be, you know, let's say 4 cores as a processing footprint. But for an analytical requirement, it might be 12 cores. It all just depends on how much work the platform has to do for the workload that you require. So it's all core-based. It's not connector-based. It's not data volume-based or concurrent user-based. It's just that way. And then it can then be deployed in the cloud, on-premise, or both. We can set up. It's very easy and quick to set up a hybrid data model. And in addition, we are available in some of, well, I shouldn't say some, but the major cloud marketplaces such as Google, Azure, and Amazon. And the cost model is based on a annual subscription. So it's an annual subscription-based cost model.
Okay. If any more questions, there's a little bit more time. So I have one more question around, in the presentation, you talked about unstructured data. How does that sort of work? Can you connect to EDRMSs or unstructured?
Yeah, so if your unstructured data is being managed in a system, whether it's a CDNS or a record management system or a service of some point, then it's actually quite easy because those systems are imposing structure on top of that unstructured data. And because we're driven on metadata, I mean, everything needs some level of metadata, we can use that metadata to start to build or include that in a model. So an example might be a call center transcript, just, you know, as some sort of example. So regardless of whether that transcript was inside a records management system or if it was just on a file system, it would have some metadata associated with it. You know, things like date, size, location, file name, etc. And we could all use those. We could use all of that standard metadata in order to include it in our logical model. The actual content of that unstructured data would then be presented as a clob if it was text, or a blob as if it was a binary file, or a large object, whatever's appropriate for the underlying source data. So now, very quickly, we've been able to unify that and deliver it out to some sort of consuming tool for an outcome. That might be a natural language engine, or it might be some sort of classification engine. But all of those engines now just become a consumer of the unified platform. Okay.
Well, thanks, Chris. We haven't had any more questions come in, so
okay.
We might
That's okay.
Wrap it up there, unless you want something else to say.
Yeah, I've just got a few slides at the end here, just some resources that the audience might be interested in having a look at. The first is the Denodo test drive. So this is a sandpit-based environment that resides in AWS or Azure or Google Cloud. If you go to the URL, it is free to use. You just register, press go. It will spin up an instance of Denodo in a cloud. It's a little closed sandpot for you to use. It will give you a script, and within about an hour or so, you'll be able to work through a scenario without having to install any software. And you can literally start it as many times as you want. So that's a very quick way to familiar yourself with some of the use cases and the actual platform itself. The other resource, or the other thing that's happening, is I'd just like to point out that on the 9th of July, we're having our CMO chair a global discussion around some of the challenges around going for cloud adoption. And you can see here we've got representatives from a customer such as Toyota, our technology partner Snowflake, a representative from Tech Mahindra, one of our global SIs, and Pablo, who is our product manager. And that's all being chaired by Ravi, our CMO. And so, yeah, I would encourage you to go and listen to that, because I'm thinking it will be quite a lively discussion, and it will be a panel discussion rather than just a presentation. And then finally, and these will be available in the presentation when you download it at the end, there's links to some other useful resources that we feel a lot of organizations get value from. So the first one being the Data Virtualization for Dummies. So that's like all the other Dummies guide. It just very quickly and easily takes you through the concepts of data virtualization, compares it to some of the other integration strategies, introduces some use cases, and really gives you a great overview of Denodo really quickly. And the other one there is just talking about how data virtualization is a great capability to add to a data integration landscape. And yeah, and the only other thing is I'd just like to say thank you for everyone for joining today and listening to our presentation and the question and participating in the survey. Really appreciate that. And yeah, I look forward to having any future discussions if there's any questions that come up at a later time.
Okay, well, thank you, Chris. Please look on the Dharma website for future events, and thanks, Chris, again, and for the presentation. And I'll be sending out an email with the recording and the slide pack in the next day or so. Okay, thanks, everybody. Bye.